Okay, let's get started. The attendance we will be making in the middle of the class, so when we have the break. I want to cover two things since we have during the break actually I have told you about the project proposal already. It was uploaded even before the break started, and then it's going to be due on 12th of March, so you have like I think 12 days, around 12 days to finish. But I think the most important part is to find teammates because if you don't have a team, then you couldn't actually discuss with them which project that you want to do. I see that there are around maybe 10 teams, or there are some teams that already chosen some projects, and they're actually chosen I think some of them already saturated some projects, like some things like Java Ref or something like that, already have 3 groups working on that. So you need to choose other projects compared to the one that already chosen, because the maximum team that can choose single projects is like 3 teams. And then also we provide a main repository for you to commit your codes. So this is if you want some place where you put everything in, then you can use this main repository. So that's actually good in the sense that you can check some kind of progress of your teammates, especially if you feel like sometimes your teammates are not performing, then we can go and look at the main repository to see like who is performing. And then but then the other thing is because some of you are not familiar with submitting to GitHub Classroom, so we have this MP0 machine problem 0. It's very simple assignments. You are going to do it during the lab today. You should be able to finish within 1 or 2 hours in the lab if you follow the instructions. And then this is just kind of like it's actually take very less score, like just 10 out of 10. So it's like compared to other assignments, it have very low score, but it's just to get you started with how to submit to GitHub Classrooms by making the README. And then I think this way of submitting, other people have find it useful, and then they actually start to use README to document a lot of things, because you can include link there, or like different things. Like we also tell you about how to create your own website using GitHub IO. If you are interested in creating your own website, you can use that as well. So that's all taught during the lab. So these are the 2 main deadlines, because the one on 9th of March is like next week. So I hope that you will actually bear in mind of these 2 kind of deadlines. And then if you have any problems of submitting to the project proposal or the MP0, then you can send us an email. But then actually, when you link your account the first time, the rest will be linked actually correctly, unless you select a wrong ID for that. So because we already have, I think, around 1 month before, after we talk about things in the previous lectures. So just a recap of this version control systems that I was talking about, which is Git, will be the things that you will be using for version control systems in your projects. And then there is some difference between SVN and then CVS and purpose. These things are actually still used, and I know that in China there are a lot of companies still using SVN, for example, for their version control system. So so that's the reason why I want you to know that there is actually a difference between the model that is supporting these different version control systems. One is centralized servers where everything is stored within the centralized servers, and then Git actually use distributed systems where a lot of operations are local, and then actually this give a speed in terms of getting the versions. And then continue from previous lectures. There is certain kind of benefits of version control systems. For example, it helps us to report the status of the components and also change requests. I think like all these things we can answer. For example, what is the components that have changed this week? What is the components that particular person's changing? So this actually, as I say, help us to keep track also of when you are actually collaborating with your teammates who actually make the change, and then which components have the most change. This actually important when you want to do fault localizations, which is to find if you think that some components are buggy and then you want to do debugging on that. So finding which components have the most change is helpful in this sense. And then which change requests are more than 1 month or priority 3 or greater. So this actually, I think, is important for your projects, because usually the change request, for example, if you make a pull request, sometimes they will prioritize people because there are many pull requests being kind of opened to repositories. And then for those pull requests that are older, they will give more higher priority. They will go and do the code review. But some will be pending, and then there is also a problem. So you may be thinking, as long as I submit pull request, then it will be entertained. But that is not the case. Actually, they still use like a timeline kind of basis. Usually, which one get open first, and then they will try to resolve this earlier. Or if it has, it also depends on the priority. If the pull request that you are making is trying to solve a very important problems, that may want to prioritize kind of closing or accepting a pull request. So this is very much related to your project. And then in terms of auditing and review, like usually they want to, some of the problems that you want to solve may be actually connected with build script, because sometimes the bug actually not really in the code, but then in the versions that is kind of depending on, like there are some bugs that we encounter that is actually depend on other libraries, and then what happens is we need to update that library. So then we want to know whether build script is okay in this sense, and then how do we know that only authorized people can change the database? I think this you usually don't need to take care of this so much, but then when you have a kind of proper projects, you may have these problems. Or sometimes people are telling me that they choose not to do that open source project because that particular open source project needs some keys that that you are not able to get. So that may be problems that make you not able to contribute to that open source project that you choose. And then you also want to answer the questions whether you can run the versions from a particular date. This is important when you want to do debugging as well. Like when you know that it has to, the bug that you're trying to fix has to do with some changes across different versions. So you may want to do debugging in this perspective. And then change controls usually have two things. Like I think this, like you will encounter quite a lot. A lot of people usually discuss whether something is a new features or whether there is a real bug. We actually allow you to make pull requests for both features and bug, but then that's sometimes depending on whether it's a bug or features, the programmers developers will give higher priority to bugs because new features that will want to test it more properly before including them to the new release. And then usually this change control authorities is like deciding which change should be carried out. If you are not the contributor of open source projects, usually you will not have the authorities to kind of push your pull request to the main repository. So, but then once they add you to the contributor, you can actually do this. You can also review other pull requests. And then there is also this problems with linking code changes with change requests. The problem is some of the bugs that you want to fix, even though there may be already a fix somewhere, but then they may not actually link the code to that pull request. So this you need to be careful because sometimes the bug that you're trying to choose maybe already have a fix but have not been merged or have not been kind of bring into the system. So maybe you need to search for whether the relevant changes is there to actually avoid fixing something that developer already actually in progress in fixing. There is example here is Bugzilla is also is similar to GitHub, I think, but then it's a database that I think it's have older history. Originally developed for Mozilla, but then it has more, I think, a lot of guidelines and a lot of field that is actually need the people who report the bugs to fill in. So actually this, I think is more well structured. It contains more information to help people to find how to fix the bugs or prioritize the bugs because it have different structure than GitHub. Like you can see that here Bugzilla have different things like which is the components that is buggy, and then it also have things like whether a bug is important, like it has like P3 majors and so on, and then there is also the people finding the bug. So this is like a view bug report filed in Eclipse. Like I was the one who filed it, so I use this as a example. But actually, this bug also, if you can look at the time when I was reporting it, it was back in 2009. But then until 2016, it's only recently modified. So actually, Eclipse have very slow kind of movement in fixing bugs because actually, apparently there are only 2 people fixing all the bugs that people reported or something like that. So they actually don't have time to fix a lot of bugs. So that's why it's this way. But when you look at the bug report, when you want to choose which issue to fix, sometimes it's important to see whether it has different kind of things to help you to reproduce the bugs. For example, here you see that there are versions of the particular systems that actually sometimes affect whether the bug will occur. And then it also have the importance, as I say, more important bugs will have higher priorities. And then I think like sometimes like people assign a particular developers to a particular bug report, so you can communicate with that reporter to that developers. I think the most important thing is the difference between Bugzilla and GitHub is that all these different things are usually available in GitHub as a tag. So like they will say like whether it's critical, major, or minor enhancements, all of this is actually a tag in GitHub rather than a field like here that is very easy to see. So that also gives some challenge because sometimes very difficult to reproduce a bug or to find whether this problem is important, something like that. So when you resolve a bug, I want to tell you that it's not always the case that developer will choose to fix it. Sometimes if you don't communicate with the developers and then choose the bug report, they actually may things that is invalid is actually not a bug. That things that will not fix. Last semester, last year, when students are fixing bugs, they actually encounter that because they didn't actually communicate with the developers. Some developers actually don't really want to fix the bugs that they choose to fix. So, which I think that they will actually either categorize this as invalid or won't fix. So that's a bad news because you spend some time in like fixing bugs, but then they wouldn't actually accept your pull request. I think if it has something like later the bug will not be fixed now, maybe it's okay. But I think they will not have so many category in GitHub. I think there maybe something like won't fix or invalids I think appear. Or duplicates. Duplicates is actually a problem in the sense that if you have a bug report that is linked to another bug report, actually it's better to fix them all together or find the bug reports where there are more discussions, because that will be basically the issues that will keep track of all the other bug reports. And sometimes they will close all the duplicates ones, or sometimes it's not exactly duplicates, but then it will be related bugs that's interesting as well, because it means that when you fix a bug, then you fix actually two bugs, because the other bug is actually related and easy to fix after this bug is being fixed. And then things to think about, like when you have different people using a change control systems, there are different perspectives. I think like in your projects, you have developers. Most of you are developers and testers. User actually, I think if you choose something like Android apps, sometimes you will have user following that bug report. And the manager, I think, doesn't really exist in your projects, but then usually equivalents to kind of like the contributors or the main authors of the projects. And then how about security issues in Bugzilla? There is also security issues is given higher priority compared to other issues, because some of this security issue will have a CVE that is some numbers that denote that this is new vulnerabilities. So if you are interested in fixing security issues, it's always good because some security vulnerability, after you fix it, you get some money out of it, but not very easy to find security issues in GitHub, I think. To make actually the software change configuration management systems works, it requires, of course, different trainings, different tools, like the version control systems that we have talked about, the change controls. Actually, I talk about Bugzilla. There are Metis, Jira. I think Jira was actually quite oftenly used for Apache projects. And then building, some of you may choose some Java projects that will use Make. I think most of them use MVN and or some Android projects use Gradle. Only C projects use Make. And then to release it, sometimes you will release to Maven Central and this Nexus. So I think Java projects, I see that they are more released to Maven Central. And then in terms of this software change configuration management managers, different complex tools will need expert to manage them. And then usually some people will be in charge of maintaining the tools or the configuration files. do the mergings and then have some policy. I think that's a little bit far from what you will do. There are some alternatives where maybe there is some supports that to support this software configuration management tools, and then there may be having some special architect to define the configuration files. Usually for open source projects, they don't have architect to do that. And then developers usually the one who merge the code back to the main line. And then there are other things like manager and technical leads will define the policy for this. So I think that's the role of the leader in your projects. If you are leader in the projects, you may decide whether you have your group mates have made significant change that you think that is ready to file a pull request. So that's a little bit related. And then this kind of diagrams is trying to show you in terms of different parts of the software configuration management. You can see that there is a main line here, and then there is an active development line, and then you will see there is some private workspace. I think this more relevant when you look at it in Eclipse, like you have a particular workspace, and then it's trying to have different kind of versions. Like I have told you that different versions actually have different meaning. Like you have some private versions that maybe you're changing it, but then not released publicly, and then there is some release versions that is important. And then there is also some third-party code lines that kind of not really related to your parts. And then after you change and then make a system, you will need to have the integration built. And then there are also different testing here after you do the build, like smoke tests, unit tests, and regression tests. I haven't go into details about the testing parts. We'll cover that in the next few lectures. So now I just will try to briefly mention what are these tests, but will not actually talk too much about testing. So what is smoke test is basically if you, I think you will not encounter this term too much in when you're fixing bugs in GitHub. Because smoke test is more like something to test your systems really fast when you make a change. But I think developers usually don't really use this term so much. But unit test, I think like all of you should know, like unit test is to test a particular unit. In Java, usually unit is like a method. So you want to make sure that this method is not broken after you make a change. Regression test, I think it's important to let you know what it is, because sometimes if the bugs that you are trying to fix is the regressions, it has a very particular setup, because it means that you have a versions where it was working and then it gets worse after that. That means that you have one version where it was working for particular test cases, and then after you make some change, then something is broken. So regression test actually is there to make sure that these changes actually doesn't break. So you need these test cases to test these changes. So if you find a bug that say is a regression, then you will need to check what is the previous version that it was working that may help you to find the fix for that bug. There is some developer issues, like for example, private workspace will we want to prevent some integration issues from distracting you. So you will want to have a private workspace, and then you can develop in the private workspace. So that's actually equivalent to if you want to fix the bugs at your local systems. You don't want to deal with how to merge with other people. You can have a private workspace, but later on you still need to merge that back. And then private system builds is also similar concept. So you just want to do like a local build without committing the changes to the repository. There are several policies that I mentioned before. I think the most relevant one will be like a release line that will usually have bug fix for release. Task branch, I think not really important so much. So I have covered mostly several aspects of the software configuration management, including change controls and then version controls, and then buildings using different systems, and then releasing. And then you have learned about different tools to do it. I think all these tools usually are supported by either Git or SVN. They actually have the support for this. And as you can see, it requires some expertise and oversight about how to do this correctly. It's more important in large projects. So that's the reason why you actually using this for the projects, because the projects they are going to choose is presumably going to be large project. Then next I want to switch more to topics to I think that more important, because that's like the software process that you will be using for the projects. That is called extreme programming. Extreme programming is also called XP. X is coming from the extreme, the second words in extreme, and the P is programming. And then this have been slides from the UIUC lectures that I was we were covering this. So for this introductions of this software process, I want to first tell you about typical kind of process, a software development process that is called waterfall model. I don't know whether you learn about waterfall model in the OAD class. I assume that you learn a little bit. And then we will try to see what exactly is XP, and then how extremely does XP differ, because we want to compare to waterfall model. Waterfall model is more traditional. And then we will cover some XP practice, activities, and notions. And then I will also tell about when not to use XP. So we are actually using XP for the project. So you may not be noticing, but then you are essentially practicing this XP when you are doing the class project. So in terms of software development process, there are actually many different ways to develop a software. If you go to a software companies, sometimes they will tell you that they use, I think, agile development process. A lot of companies using. And then I think like because it's actually very much practical kind of process. And then there is also something like plan driven. I think it's not very formal kind of software development process, but agile is like kind of more formal. And then there are also ways like centralized versus distributed. Like some people, if they are not using version control systems, they may be just saying that they just throw everything into a folder, and then you can share with the folder with others. It can be high math versus low math. I think that's about the software that you are developing. Another thing is that whether you have close or little customer interactions. This is important because XP actually assume very close customer interactions. So this happens when you, for example, have someone who literally telling you what is the things that I want to do, and then so that will actually keep communicating with you. And then there is also some that do a lot of testing, some that do very little testing. I think that's in the class, we will actually prefer more testing. And then there could also be organized by architects versus architectures versus the features. So the architectures sometimes could be like some software that are supported in many different platforms. So that could be organized through that. Or sometimes it's just organized by features because it doesn't really have so many branches of different platforms. So what is actually a waterfall model? Waterfall model is actually have several parts of this waterfall model. I think that should be easy to understand. Like usually requirements is what the software should do. Usually you get requirements from any place. It could be in natural language, like just someone telling you that I want this to be done. Or it can be something like requirements in terms of more formal documents that you need to read what should be done. And then design actually will be more about up to you, kind of how you structure the codes into different models, architects. Usually for the class projects, for each of the projects that already have a design. So you should follow their design actually. And then implementations is basically the one that you are most familiar with, just hack code, just do programming. And then integrations is more difficult because after you fix the bug, other people in your team fix the bugs, and then you want to put everything together. That's become very difficult because you already will have different things like conflict. And then testings is basically to check whether code is working. And then maintenance is like you make the changes. So this is like different steps of the waterfall model. And when you do integration and testings, usually a lot of times they want to merge together because integrations, when you do integration, sometimes you want to make sure that you have tests to see whether the whole models when merging together is actually makes sense. So this is the model of the waterfall model that have several steps. It's like a staircase if you look at this. So it's like first you start with actually that's the reason why it gets a name waterfall. It's like water falling down. So it's very much step-by-step kind of process. First you start with requirements, someone telling you kind of what to do. And then you go and design this, and then you go and implement this by coding. After that, maybe you do some integrations together with testing to check that the code that you write actually makes sense. And then after that, you do maintenance when you get some bug reports, and then you kind of change your software. So the waterfall models that is in real life actually, because this kind of process is not really practical. Usually you want to actually add some kind of things in the back loop. That is, so you can see here we add something like analysis. We want to do some analysis to check whether we meet the requirements. And then design, we can also do some checking. And then implementation-wise, we can do unit testing. And then after that, when we do integrations, we can do system testings. And then when you do maintenance, and then you find that there are some change that maybe will break some code, then you have regression testing. So in real life, waterfall models, even though it's like very rigid, like step by steps, but then it actually have supported by different checking at different level to make sure that all these steps actually is correct. Because there is problems that if there are one step that is incorrect, then if you fix it only in the maintenance steps, then you will actually be very costly. So in terms of extreme programming, it's oftentimes used to contrast with this waterfall model, because waterfall model, as I say, is like a waterfall, very rigid, follows step by steps, starting from the requirements to the end when you do maintenance. So, but then we want to have a more practical, kind of more flexible model. So that's the reason why XP was being introduced. It has a more collaborative kind of model, and then also more iterative kind of models that you can go back and change something. But the main idea, I think maybe this, like the things that is what you like, because I think that most of you don't like to write much documentation, but the key idea is, even if you don't write much documentations, if you write more tests, then you can replace the test cases as a documentation. So so here they actually advocates you to write a lot of code together with the test cases as the main product. And then the other main idea is that we, instead of basically implementing the whole features in one go, like for example, you can actually fix the bugs in like just one day or something like that. But then the problem is they're actually trying to advocate that you want to fix something slowly, step by steps, so that you can make changes after that. So that's also have this code release that is frequent, that is trying to release each day. And then also the other things that I mentioned, that is working very closely with customers to check whether you meet the requirements. And then also a lot of communications with team members. I somehow think that this communications with team members actually kind of helpful for last year when students are actually back at home, don't know what to do, and then they're maybe more effective because they feel bored at home, and then like trying to communicate with their teammates to fix bugs, give them some kind of things to do. But I hope that like with the offline kind of teachings, you will be able to be more effective compared to students who work online. Next, I want to kind of pass. I think I put these slides online, so I think you maybe know the answer to this. But like, maybe I just try. Okay, I I think that a lot of you look at the slides because how many of you look at the slides and get the answer? Okay, there are some that are honest, because a lot of people there are. I think like the problem, the things with Cam back is that he is still actually active in you can still find his Twitter. Actually, I think I follow his Twitter as well. So he is still active in the in like promoting XP, and then he's also, I think, the one of the gang of four for the the design patterns book that you may have read. And then I think the one interesting part is that because you in Chinese we have these things like called Ma Nong, that is coding peasants, but he's literally farmer actually, and he actually trying to make an analogy between goat farming and software development, which I don't really know. If you are interested into why is the software development process actually similar to goat farming, you can go and take a look. But yes, I just want to say that the software development process actually, especially XP, is not really carried out in many companies, but then some of the concepts I think is useful, and then it's actually been adapted to other software development process. Some of the key practice of XP includes, I don't know whether we have time today, but and I don't know whether it's too slow, but we may play a game. If it's not to these lectures, maybe next lectures, we may play the planning game for requirements to see whether you can actually kind of know how to do estimations for given the requirements. Another thing is test-driven developments is important, and I think like maybe next week I will show the video. But I think the video for how to contribute to open source projects that actually students actually uses still test-driven kind of developments, but not really officially, but have shown to help him to find like how to fix the bugs. And then refactorings, I think all of you may be using already refactorings if you are using IDE, like especially for Java projects, there are very good refactoring engines in the IDE, like including even Eclipse or IntelliJ have very good refactoring engines. And then pair programming, I think like it's very interesting concepts. And actually that's what we will cover today. And then also continuous integrations have been used for very long time and still very popular. So XP itself is an iterative process. That's as I say, it will be the software development process that you will use for the projects. And what do I mean by iterations? When you do the project proposal, you will realize that I mentioned these things about iterations there. So basically, in XP, they want to have like 2 weeks as a cycle. 2 weeks cycle usually like it can be it's not really strict, like can be 1 to 3 weeks kind of in the middle, like 2 weeks. So basically after every 2 weeks you will have something being released, kind of it can be small release, big release, but the things is you organize things that to be released into an iterations, and then you want to plan each iterations in an iteration meetings that is held at the start of each iterations. So basically, you and your teammates will meet up and then trying to say that each iterations, what are we going to cover? And then each iterations will implement a set of user story. I will talk about what is user story later. And then we want to divide the work into tasks that is small enough to finish in like a day or so. Sometimes this is very tricky. But then each day, because XP also talk about pair programming, so you can work in pairs to finish different tasks. So this is like one of the main concept of XP. I don't know whether this will be feasible because last time people say it's too slow. Let me send the link. So the reason that I want to do this through GitHub Classrooms, I want you to trying to see how to do team assignments in the link because otherwise you don't get so much practice compared to your lecture or assignment. So do any one of you have problems? So so you don't need to, you can form the team and then people will choose the team name. So I just want to give you a practice of how to do group assignments, as I say. This is not going to be graded anyway, but so it's good practice for the projects because I think like some of you may have problems with collaborations for the project. So you don't need VPN to go into GitHub Classroom, but sometimes when it was too slow, you can use VPN to speed it up. Actually depend on their speed. But as I'm not connecting to VPN here, but I can connect fine, but a little bit slow. So I already see that some of you have like some team members, but I don't know, like one team somehow have two chow. I don't know why. But be more creative in the name. I mean, you can choose a new name. I mean, because when you form a team, sometimes I can choose to use the team from, like, say, the old group. Like, for example, for the class projects, we use the old team that you have already formed for the project proposal. But for this, it's just randomly formed team. So, okay, the instructions is that you want to go into 3 neighbors, and then this also so that other the online students could to do that, and then basically you can open an issues, and then once you have this title, and then we want to share and discuss with your group mates about what is the pros and cons in working in teams or solo work. The thing is, this also kind of give you a feeling of how you can collaborate with your teammates if you want to discuss how to implement an issues, because in GitHub, I think it's easier because you can click on the link, include the link in the discussions, and then so it makes the collaborations of discussions about issues much easier. And then I will try to see, it's showing that you don't have any commits because I think that's like the case. But, yeah, as I say, like Without using VPN, it could be very slow. Okay, I will try to see from my phone. Okay, it seems like all of you still have some problem of where to click. I will give you more time when I'm also clicking myself. Anyone have any questions or problems? I don't know. Like I saw that there is this team have actually opened an issues that I'm not able to see here, but I can see in my phone. Oh, okay. Now it's already. So sometimes you just need to like kind of. So I don't know. Like the answer was quite strange, but I think like just trying to test. But I think you already try opening an issue in the last lab, the lab before the first lab. You have tried to. The GitHub bot was telling you how to open issues and communicating, but now I think like the difference is just that it's the team setting, and then it's give you this experience of what you could do if you want to communicate with your group mates by opening an issues and then discuss. Even though I don't know, this sounds not very useful. And then they say that there is a trade-off, like solo work may be limited to information cocoons, while teamwork may have low efficiency. I guess that's also kind of the case. But I think like I saw that most of you have no problems in opening issues. At least. Okay, I will give you more time because some answer is like meow 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 or something like that. I don't know. So I see that. So it doesn't matter which one you select. You can just select whichever that still available, I guess. I think some of you still have a problem connecting. I think with VPN, it's faster to connect for me. Mhm. Okay. So. I don't know. Suddenly, a lot of people leave the classroom for some reason. So just to remind you that the sign up will be during the break. 可能大家突然间想要
反正打开了，到时候他们没钱了，到时候再加。
这个是它有那个什么的吗？
对。
就是这个是你要设定时间的。
到时候会。
我的3年，怎么我的少不到呀？啊，没有，这个普通微信，这个是，对。就少就好啊。
没加入课堂。
没有加入课堂。说到课堂编号是什么呀？编号。
再放一个。
哦，就有另外一个要扫嘛。如果还没加入课堂的话，好像要扫另外一个码，还是要怎么加入课堂？
你可以直接归注教室。
哦。GF777是吧？哦，就是要去找那个为助教，就在那个就在微信上面找为助教。如果你还没有加入课堂，就是要先找到那个，然后要那个偏好像是 GF777，然后才能，这个是你已经之前加入的，就不用再加入一次。 啊，我这已经什么吗？为什么突然间就结束了？哦，再开始呗。 Okay, I guess all of you already finished signing in, and then also I think I saw some of you already answer the questions, and then I have problems connecting with GitHub in here, but now it seems okay. So I guess the trick is to refresh several times until it works. I don't know. Okay, I just picked these two teams because I like that the name, one is bug free, one is full of bug. It has a nice contrast, but both are kind of like not answering questions. So I think there are a lot. I am kind of surprised. Like I thought programmers usually are more isolated, but it could be because Chinese people are more like teamwork more. I think that could be one of the reasons, because it's like a community-based kind of society. So a lot of the answer that I saw, that they say teamwork is very good, and then they need to encourage teamwork, and then you can make use of others' ability more efficient, and then solo work get more pressure. But I think that's different on culture, because like in other culture, independence, being independence is more encouraged in some sense. I think I saw this answer in my phone. Now it's not working anymore. So this, I think this group was saying that I think this I have read this for last time. So let's see whether there are more. So any group want to volunteer to I don't know what is the answer that because there are some that without any answer. So any group want to volunteer and then you get some stickers. I don't know, like because I mean like it's difficult to find groups that actually make valid comments, especially with the connections that is not very good here. So so I couldn't find actually any valid answer like the other one that I already read. And then there is one that I saw that is this, I don't know, like there is one group that is like boys same, but then the one of the person deleted the commands and then self-assign. I don't know, like maybe it's to test the features in this. I saw one other group is Hello World. And then there is one close comments. Okay, Hello World just really say hello in their things, in their comments. So I guess people are still kind of testing the features of how to check in a team. Like I say, the team here is set to be just class discussion team. So it's not the real team that you have in your project. It's just so that you can try to see how to create discussions and then discuss in the group chat. Okay, I saw one group at Star Sky 18 that have make the comments about in some projects where the divisions of labor is difficult, cooperation is just write code serially. I guess that's also talk about at least this first group that I saw that talk about the disadvantage of working in a team because sometimes to divide the work is quite difficult. I think that's also a valid point because like especially for some issues, like if you want to fix a bug, sometimes it's not really easy to kind of do it together because like it could be very simple kind of thing. You don't need to further divide. So I think that's also the problem. Basically, like I saw that more people are leaning towards teamwork here, and then some say that it's difficult to divide tasks for certain things, and then I think the same group also say that teamwork can reduce the workload, which I think is kind of true. And then there are also things that say teamwork is more efficient. I think a lot of people say efficient. I think like efficiency also like depends. Like it can also exchange different ideas. I think that's also valid point because you have more people to kind of discuss idea, and then like solo work is like you have the freedom to implement the things that you wish. I think that's all. I think you know what is the benefits of teamwork versus solo work. That's why I picked these questions because it's not so difficult to answer. Like there is no kind of definite answer, but because you already work for alone for some assignments in your course, and then like work in a team, like just like to get your opinions of what is your take on that, like whether you like teamwork versus solo work. And then that also brings me to this concept in XP that is quite, I think, prominent. There is pair programming. Pair programming is very simple. I think straightforward concepts, and then that basically means like a pair, like two programmers is working side by side, and then usually have one computer, but then there are many variations that have been proposed that say you can work remotely, but traditionally it's supposed to be like one computer and then two people sitting side by side continuously collaborating on the same design, the algorithm, code, and test, and then it is known that the benefits should be to produce higher quality codes because it's actually getting the expertise from both people. And then there are two concepts kind of in pair programming. One is the driver. Driver is someone who types and writes. Usually if you type faster, maybe you want to be the driver. And then the navigator is the observer. Usually is good in looking bugs, looking for different design kind of bugs as well. And then but you can actually switch roles. It's actually recommended to switch role a little bit so that you don't really get tired. The driver don't get tired of like typing, and then the navigator don't really get tired of looking in the screen. And then possibly like 30 minutes or less. So you can do pair programming like for coding, design, debugging, testing. I have tried this, but I think I was a navigator in like when I was trying the pair programming, because not really fast in typing, but good in looking for bugs, I think. So like I think this like a comic like about pair programming. Like someone said that we're going to try something called extreme programming, and then I think this is the boss, and then he said that first pick a partner. The two of you will work at one computer for 40 hours a week. And then like it sounds like very long pair programming actually, like 40 hours a week. And then the new system is 1 minute old, and I already hate that because I guess like people maybe have some kind of wrong impressions of pair programming. And then I think that more pictures of like what pair programming should be like. I think this pictures is I think people from Google, like they were doing I don't know, remember this which picture it is, but then this is to show like you really can have someone like working in like as a driver, like you can see one person holding the keyboard, the other person like really working with it together, and then the other picture you see that there is a pointing like saying that which part have a problem. So that's basically kind of like showing what's pair programming like in person. But this is not really pair programming. I think this is like a little bit violent. But I hope that you will not learn this. But that's like kind of really okay. I don't know, want to show too much, but like I guess you get the point. Like we don't if pair programming get ugly, it could be but I think that is not really pair programming, because like you can see that two the way that they are standing. I don't want to show that the previous slides, but you can see that person was actually standing, and then the other person was like programming. So it's not really pair programming as such. It's like bossy kind of thing telling you what to do, and then like become very angry. So pair programming should be kind of like this, like you can achieve the benefits of together as a pair. And then there are actually, it's not like just kind of, no, just what I say that is good. There are some evidence from industry that they can actually produce nearly defect-free code in less than half the time. I think this is the ideal case. If you can have faster, because some show that pair programming actually is slower, but this actually depends on how well the pair is collaborating. But in general, they say that there are some studies saying that it produces higher quality code because you have someone looking at it and then trying to find bugs. And then you can complete the task in about half the time if you are efficient. Like if the pair is like not really doing something, only the driver is keep typing, the other person like sleeping, for example, then it's not possible, of course. And then the other thing is, I think like emotionally, pair programmers are happier programmers because I think that's the previous pictures. You can see that they are kind of very happy, so it's good for because they enjoy their work more. Like you get like a sense of achievement together when you fix the bug, for example, and then you feel more confidence in the work products that you produce. So expected benefits include higher quality codes, improved cycle time, and then also the programmer satisfactions. And then sometimes if you get the good pair programmer, you can learn from them, like how to program in a style that is good. And then also if you have a pair rotations, for example, within the group, you don't just work with one pair. If you work with other pair, you kind of also build relationship with the other persons. Then you can kind of collaborate more. The ideal case is that if, like for example, one person is good in like writing good code, then you can learn from that person, and then like the other person will be like good in debugging and testing. Then you can learn from that person. Then essentially at the end, then you learn from both persons, and then that's the best case, of course. So it's also reducing the product risk because you have people who look at it when it's designing. And then so that's one of the benefits, like it enhanced team building in this sense. So for the projects, you can work in pairs, but then pair rotations have some benefits. But of course, like because if like you are more compatible with this person in this pair, and then you can more likely to learn something, the other person is a weaker person, then you will not get this benefits. Pair rotation may cost some more time to be spent in like collaborations, communications. Example of good pair programming include like these two Google senior fellows that actually shows that they actually do pair programming. I think now they no longer do, but then they actually say that there are some kind of articles that there is the friendship that makes Google huge, because they actually explain that I don't know why more people don't do it, because you want to find someone that you can pair programs who is going to be compatible with your way of thinking. And then so the two of you together is the complementary force. I think this problem is like in a company, maybe it's not really easy to find someone, but it's known to actually have some benefits at least if you find the one that is compatible, as you say. So there is some issues like partner issues. I think that some of you may have think about this when you talk about the benefit, and then also disadvantage about solo versus teamwork. Because when you are pairing with a partners, they usually have a problem. Like if you have an expert pair with an expert, then maybe it's okay, but depends on personality. Because if two experts are very stubborn, then it's maybe a problem. You may spend a lot of time in arguing. And then if you pair an expert with a novice, you may drive the other person crazy. And then like that may be having some more issues. And then if novice pair together, even though it's compatible in terms of expertise, but then it may also have more problem because if both of this novice guy are actually just talking about other things like chit-chatting instead of programming, then you will not be very beneficial. And then also could be having some professional driver issues, like someone like almost like a robot keep typing and then do not listen to the other person. That's also may have some issues. Or it could have more culture issue, I guess, like you don't really have this problem so much because presumably you are, if you just collaborate with others, unless you pair up with the international student team, then you may have some culture issue in understanding each other cultures. And then the other issue I think may be interesting to you, like because you saw the pictures of pair programming, good pair programming. So if you want to work with pair partners, then it's best if you do this layout in this sense. If you have L-shaped kind of corner, and then because you will not be able to, you are blocking the other persons in that sense. So if you move the computer to there, and then where you can use that corner, and then two persons can look at this, it's easier to do pair programming this way. But the best way is like kind of like this, where you have one line and then like people sitting together in. I think when I visit Google, they have the layout a little bit like this, but then not really the one in the middle. So there is mostly advocating the benefit of open space kind of workspace, because you can kind of communicate. There are some that actually have cubicle to separate people. I think there are this disadvantage and advantage in this, but we'll not discuss about this. And then there are some issues also in terms of process, because pair programming is really an old concept. Even though when I tell you this, you may think it's quite new or something like, but actually it's quite old already since the beginning of programming, because obviously if you can do anything in pairs, but it's used very extensively in extreme programming, also in other development process. And then the thing is, it can be added to any process if you want to do pair programming. So how do it works? I think that is also, someone talked about pressure, I think in one of the disadvantage, like someone say that for a single person, you have more pressure for solo work. But I think that is two perspective. Like in the pair, you may also have pressure. That is like if you have like very high difference in terms of expertise, then because of pair pressure or something like that, you may want to work harder to kind of achieve or learn from the best. So you may, but this pair pressure can be good because you can keep other on the task and focus, and then you don't want to let the other partner down. And then you may also be embarrassed to not following the process. I think that's help in certain extent, especially when you have a weaker team members, or not. Sometimes it's not really exactly weak. Sometimes people are with less confidence, but when you work with a person, you realize that you're not that bad. That also gives you more confidence. And then there is also pair negotiations. That is like when you are searching through a large space of alternative, because when you want to implement something, you will realize that the way that you're thinking in mind may be different from the way that your partners is actually thinking. So there are a lot of different alternatives, but you have a shared goals of implement the same thing. So you can bring different experience to the task and then different access to the relevant informations. But you have to spend some time in negotiating to a common shared actions. And then also, I think pair courage, like if it looks right to me and looks right to you, is probably right. I think that's kind of like a way to kind of persuade yourself, because if you feel like you write a code and then you think that it's not really correct, and then you can ask the other person to look at it, and then the other person also look at it and thinks that it's correct, then maybe it's likely to be correct. So all of this is kind of like effect of pair programming. And then also pair reviews, like 4 eyeballs are better than 2. And then I think it helps more like in design and code review. And then also remove the programmer's distaste for review, because I think all of you will be very afraid of making a pull request, letting the developer making a code review that will pick up a lot of problems. But then if you let your teammates to first check and then you look at that, then because you already have someone looking at that, you will feel less reluctant to kind of let the developers to look at your code. And then also, I think debugging is most important thing. Like I think sometimes when someone is typing, I can see that they are making a mistakes, and then like I like to point out the mistakes as well. And then also pair learning, like is important. Like taking turns being a teacher and the students like also help in this sense. But pairs really means that working together. So the two of you, like for example here, it shows that you'll be code writing team, and then study proof that 2 programmers on one computer is most productive. And then but then this guy was saying sometimes I can whistle through both nostrils, and then I have saved a fortune in harmonica. It means like actually the person, the navigator here actually just taking a cup of coffee and then really relax while the driver is working. So this is not really working together. So if you want to try pair programming, you can try, but then it needs to be kind of way of 2 person actually working together to get the benefits, of course. And then I also want to introduce to you this thing that is kind of new. I didn't talk about this last semesters. But basically, when I find like whether there is because I teach you about Git, and then I encourage pair programming in the projects. But then what happens is that if you want to commit to the repositories, usually in the default setting, only one authors will be committing this. But then turn out that there are some projects that you can download, some extensions that allows you to add 2 authors. So I haven't go and try these 2 tools. I don't know which one works better, but I think that they have some stars. People are starring this. I think that it should somehow work, one of them. But the idea is that you can see that you can configure this, and then when you do the mock, Git mock, for example, these are 2 projects. You can try which one works. So this, like, if you do Git mock, it actually tells you there are 2 authors. So this actually helps to acknowledge your partners when you're working together for pair programming. Because if you just use the default setting, only one person is the name of one person is actually recorded. Git pair apparently do the same thing. So when you do this Git pair, for example, you can see that the author here, they do the configurations, and then the author here become someone like Augusto plus Nelson. So this is so that if you work in pairs for pair programming, and then I think the other way, like, is more troublesome, is that you can include the name of the other person in the commit message, saying that you're doing pair programming with this person, and then include the commit message itself. But then that is too troublesome because you need to include it for all different commits. But here is just to set up this so that it's showing in a nice way that you have author something for something, and then or this git mob. I think like this one has more stars than that one, but I don't know, like in terms of which one is easier to use. Depends on what is your setup. I think like this seems to be having a VS Code extension, but that if you use Bash, that's easier to set up. So that's the things that encourage you to do pair programming, but acknowledging your pair partners, because sometimes you may think that someone keeps committing, and then you say that, but I'm working together with this person, so what can I do? So you the questions, the answer is that you can use some of this extension to Git, or you can add in the commit message that you are working together with this person, but you need to add this in every single message that you're working with this person. So that's the troublesome part. But then this one, you need to install it by yourself, set up correctly by yourself. Then you can do this. Either way is fine. And then, I say, this one of the these are most of the key process in XP. That's basically talk about iterations, iteration planning, user stories, and then working in pairs. So what is a user story? User stories actually is kind of like it's like the name, what it suggests. So it's some documents that you write, and then you need to represent usually a features, a customers, what the customer want in the software, and then the thing is here is considered it should be the smallest amount of information. Okay, since we reached the end of the lectures, I will stop here. If you couldn't sign up during the break, you can talk to me. Otherwise, I will see some of you in the lab.